All right, so this is the lecture for section 2.2. So for number 13, the first thing we're going to do is we're going to see if the ordered pairs that are given are on the graph of the function or the equation that they give us. So let's just say that for the sake of argument, this is x, this is y. And so I have, some function, some equation that looks this way, right? And so what we're trying to figure out is if on this point is, a point x1, y1. And so the way that we do that is that we plug in the values for x1 and y1 into the equation. And if we get a true statement like 3 is equal to 3, 5 is equal to 5, then that ordered pair is on the graph of the equation that was given. If we get something like 5 is equal to 3, then the point is not on the graph. And so that's what we're trying to determine by plugging in these values. So the first, so remember, always is going to be, in this case, xy. It's going to be 0 is equal to 0 to the 4th power minus the square root of 0, which means that 0 is equal to 0. So therefore, the point 0, 0 is on the graph. So the next one, we go 1 is equal to 1 to the 4th power minus the square root of 1. So that's going to be 1 minus 1, which is equal to 0. So this is false. And so therefore, the ordered pair 1, 1 is not on the graph. This is. And the next one is going to be 4, 2. So it's going to be 4 is equal to 2 to the 4th power minus the square root of 2. So 2 to the 4th power is 16. So you can obviously see that this is going to be false. So the only one that's it's on the graph is going to be the origin 0, 0. So for number 19, we're going to go ahead and find the x and y intercepts. So if I want to find the x-intercepts, I set y is equal to 0, and I solve for x. This is for the x-intercept. For the y-intercept, I set x is equal to 0, and I solve for y. So the first one is I'm going to make y 0, and I'm going to solve for x. So this is going to be negative 2 is equal to x. So then my x-intercept, I'm going to go ahead and just put it here as x-intercept, is going to be negative 2, 0. For my y-intercept, I'm going to make x is equal to 0, and I get y is equal to 2. So my y-intercept is going to be 0, 2. So there are ordered pairs. And so those are the solution to number 19. For number 21, we're going to do the same thing, right? We're not going to graph any of these, so not now. And so I'm going to make y equal to 0, and again, I'm going to solve for x. So 0 is equal to 2x plus 8. I'm going to subtract 8 from both sides. I'm going to divide by 2, and I get x is equal to negative 4, so it's negative 4, 0 is my x-intercept. The next one, I'm going to make x 0. I'm going to solve for y, so it's going to be y is equal to 2 times 0 plus 8, which is really going to be 8. So then my y-intercept is going to be 0, 8. So those are my intercepts for number 21. For number 29, the same thing, right? It doesn't matter what it looks like. We're going to do the same thing. So I'm going to set y equal to 0, and I'm going to solve for x, right? So then it's going to be 9x squared plus 4 times 0 is equal to 36, which means 9x squared is equal to 36. I'm going to divide both sides by 9, right? And so I'm going to get x squared is equal to 4. I'm going to take the square root of both sides, and I have to do plus or minus. So x is equal to plus or minus 2. So then it's going to be 2, 0, negative 2, 0. Those are my x-intercepts, right? Then I'm going to make x equal to 0, and I'm going to solve for y. And so when I do this one, right, this is going to be 9 times 0 to the 2nd power plus 4y is equal to 36. 4y is equal to 36. This is 0, right? This term right here is going to be 0, so that's going to go away. I'm going to divide both sides by 4, and I get 9. So then my y-intercept, so this is the x-intercept, and then this is the y-intercept. It's going to be 0, 9. And that's how you do number 29. That's how you check for, or you find the x and y intercept, right? Now, when we're looking for symmetry, there's a couple of things that we have to do first. So if you, I'm going to show you, well, I'm going to tell you which page in the textbook we can find the explanation to this problem. Let me just go back to the textbook here real quick to see on which page we can find the explanation to finding symmetry, right? So for the x-axis, what we're going to do, so we're going to replace y with negative y. And if we get an equivalent equation, then it's symmetric with respect to the x-axis. And for this one, we're going to replace x with negative x. And if we get the same equation, then it's going to be symmetric with respect to the y-axis. And then the next one is the origin. And we're going to replace x with negative x. And we're going to replace y with negative y. And if we get the same value, then it's symmetric with respect to the y. And that's on page 162. So page 162 in the textbook here. Let me get back to number 31 here real quick. So number 31, what we're going to do is we're going to say, okay, what is symmetric? If this was symmetric with respect to the x, then I would have 3, negative 4. If it was symmetric with respect to the y, then I would have negative 3, 4. And if it was symmetric with respect to the origin, then I would have negative 3, negative 4. Same thing for number 35, right? It's going to be 5, 2, and that's going to be the x. It's going to be negative 5, negative 2, and that would be the y. And it's going to be negative 5, 2 if it was the origin, right? And all I'm doing is just doing this right here to find a point that would be symmetric with each one of these. Now, when we do this, which we're going to do in the next equation, if we get something else, then it's, of course, it's not symmetric with respect to that particular thing, either the x, the y, or the origin. And it's possible that we get something that doesn't work for either one of them. So for number 57, the first thing that we're going to do is we're going to go ahead and find the intercepts, right? So 0 to the second power, x plus 4. So my x-intercept is going to be negative 4, 0. Now my y-intercept is going to be y squared is equal to 4, right? Which means if I take the square root of both sides, it's going to be plus or minus 4. So y is equal to plus or minus 2. So it's going to be 0, 2, and 0, negative 2 for my intercepts, right? And then, of course, there's going to be negative 4, 0. I might have to move 61 down, and if I have to do that, I'll go ahead and do that. So now I'm going to test for symmetry. So I'm going to let y equal to negative y. So negative y squared is equal to x plus 4. Now negative y squared is equal to y squared, because negative y times negative y is just going to be y. And so therefore, this is the same as the original. And if it's the same as the original, then in theory, I don't have to do the other ones because I already know that it's symmetric with respect to the x. And so therefore, I can stop, right? I'm going to stop there, and I don't have to do the other two. So that's kind of nice if you get the first one to be it. So for number 61, we're going to find the intercepts again. So x squared is equal to 0. Oops. x squared plus 0 minus 9 is equal to 0. So x squared minus 9 is equal to 0. That's the difference of squares. So it's x minus 3, x plus 3 is equal to 0. And you can clearly see that x is going to be equal plus or minus 3. So then I'm going to have negative 3, 0, and 3, 0. Now for the y, I'm going to make x 0, right? Which we've done before. So it's going to be 0 squared plus y minus 9 is equal to 0, which means that y is equal to 9. And so my x and y intercepts are negative 3, 0, 3, 0, and 0, 9. So now for the x, I'm going to let y equal to negative y. So it's going to be x squared plus negative y minus 9 is equal to 0, which is x squared minus y minus 9 is equal to 0. So that's obviously not the same, right? That is a different function, so it's not symmetric with respect to the x. So now we're going to let x equal to negative x. So negative x squared plus y minus 9 is equal to 0. Just like the previous one, right? We get that negative x to the second power is the same thing. It's going to be the same thing as x squared, right? And so this is the same. So then this is symmetric with respect to the y-axis. And then just like this is symmetric with respect to the x-axis. So that's number 61. So let's go ahead and go look at number 67. We're going to do the same thing that we did in these previous ones, right? We're going to find the x and y intercepts. So 0 is equal to x squared minus 3x minus 4. And so 0 here, we're going to factor this. So it's going to be x minus 4, x plus 1, which means x is equal to 4 and x is equal to negative 1. So the ordered pair will be 4, 0, negative 1, 0. So the next one, we're going to make x equal to 0. You can clearly see that y is equal to negative 4. So then it's going to be 0, negative 4. All right, so those are my x and y intercepts. So the first thing was going to let y equal to negative y. So it's going to be negative y is equal to x squared minus 3x minus 4. If I multiply everything by negative, then you can clearly see that that's not the same, right? So here we're going to let x equal to negative x. So y is equal to negative x to the second power minus 3 times negative x minus 4, which is going to be x squared plus 3x minus 4. So this is not the same. And this is also not the same, right, for 67. And then now we're going to do is we're going to go ahead and do the x and y. So, right, so we're going to let x equal to negative x and y equal to negative y. So negative y is equal to negative x to the second power minus 3 times negative x minus 4. So it's going to be negative y is equal to x squared plus 3x minus 4. And if I multiply everything by negative 1, I'm going to get the following, which is different. So then this one is not symmetric with respect to the x, the y, or the origin. So here's the last one, number 71. So we're going to go ahead and do the same thing. Here we're going to find the x and y intercepts. So 0 is equal to negative x to the third power, x squared minus 9. I'm going to multiply both sides by x squared minus 9, so I get that. And then so here, x is just going to be equal to 0. So that means that it's going to be the x and y intercept are both going to be the origin, right? There's no need for me to make x 0 because I'm going to end up with the same thing, 0, 0. So now here we're going to let y equal to negative y. So it's going to be negative y is equal to negative x to the third power, x squared minus 9. And so what happens is when I multiply everything by -1, I'm going to get this, which is different. So it's not symmetric with respect to the x. Now I'm going to let, to the x-axis. So I'm going to let x equal -x. So y is going to be equal to that. And then this is going to be -x to the second power minus 9. And so this is going to be x to the third power, and then x squared minus 9. Again, that is different, is not the same as the original. So the next thing I'm going to do is I'm going to let y equal -y, and I'm going to let x equal to -x. So -y is equal to -x to the third power, -x squared minus 9, which is going to be x squared minus 9. And if I multiply everything by -1, I'm going to get -x to the third over x squared minus 9, which is the same. So then it's symmetric with respect to the origin. And that is the end of 2.2. Thank you.